Welcome to the course on advanced machining process. Today we are going to discuss a new topic that is called chemical machining. So today we are going to discuss chemical machining process. So first we shall give the introduction. So it is a very ancient process, well-known process. It is being used for long years for engraving the metals, for ornaments and other purposes. So it removes the material in a controlled manner by the application of a maskant. So maskant is nothing but it is a layer of a chemical resistant material which does not allow the etchant or chemical to react or reach with the workpiece surface and dissolve it. So this etchant is used for dissolving this material or for machining purpose. It dissolves the workpiece material by chemical reaction. So this is the schematic view of chemical machining process. Here this is the workpiece. On this workpiece, this chemically resistant material, that is the maskant actually used. A maskant layer is used, deposited on the workpiece surface, and this is the second one. After that, this maskant from some selective area, this maskant is actually scraped or removed from some selective area. So it is exposed, that area is exposed, this material of the workpiece is exposed in that area for machining purposes. So this is the area which are exposed where maskant layer is removed. Now this is the third step. In that third step, this with that etching or from using the etchant or chemical etchant, this chemical machining process goes on, and after machining for certain amount of time to get the certain depth, machining depth into that workpiece, so that etchant actually, this workpiece is removed from the etchant bath. So you can see here this kind of tapered surface is made by using this chemical machining process. So this kind of tapered surface, and here you can see overcut is there. So it should be perfectly vertical, but this kind of overcut is there and tapered surface is generated by using the chemical machining process. So here you can see this maskant steel, it is attached on the workpiece surface where we don't want any machining. So in this area we don't want any machining, so maskant steel is attached. Now after that, this maskant is removed from the workpiece. Here you can get the final machine surface. Okay, so from here this whatever maskants are there, it is removed. So here this is the tapered angle. So this is the disadvantage of this process. This kind of tapered surface is generated, and here this kind of overcut is generated. So after machining, this workpiece is clean. So before machining, before attaching or gluing the maskant on the workpiece surface, this workpiece is clean. So initially it is clean, and after that also it is clean. Workpiece is clean, and you can get this kind of surface. So very intricate geometries can be generated from this machining process. So here you can see this is the etchant bath. So this internal surface of this etchant bath, you can see etchant resistant lining is there, so that it should not make chemical reaction or it should not dissolve the etchant bath material by chemically dissolving it with the etchant. So this kind of etchant resistant material lining is given at the internal surface of the etchant bath. So this bath is actually, it is filled up with etchant, and this is the workpiece which is hanging with a rod. Now here you can see this portion we don't want any machining, only this portion actually we need the machining. So other portions where we don't need any machining, this maskant actually it is deposited or glued on the workpiece surface. After that it is dipped into the etchant bath. So this area where machining is required. So this is the etchant container here, and sometimes heater coil is actually required. So whatever this etchant material is there, it can be agitated by heating this etchant by using a heater coil. And sometimes this heater or this etchant actually it is agitated by a agitator. So here there is a rotating device is there. Using this rotating device, this agitator or a rotating device or agitator, this whatever this etchant is there, it is actually properly circulated inside the etchant tanker or etchant bath. So this workpiece actually it is dipped into that etchant bath for a certain amount of time for getting a certain depth of cut. So for suppose this is the depth of cut here. So this depth, for getting certain depth, from preliminary experiment you have to have information how much time you have to keep this workpiece inside the etchant bath so that proper machining can be carried out, or proper depth of cut or exact depth of cut can be carried out. So these are the different applications of chemical machining process. So it is used for producing complex configurations in delicate parts. So you can see that jewelries, different jewelries actually it is made up by chemical machining process, chemical engraving process. So these are the intricate components into that jewelry. So it is made by this chemical machining process. By controlling different process parameters, it is possible to make intricate components into that workpiece surface. So aviation industries it is used extensively for making the aircraft wing panels. So these aircraft wing panels, it has certain curvatures are there, and these are the very big panels. So these big panels are actually made up by this chemical, can be made by chemical machining process. So to manufacture very thin laminations without bars. So this advantage is that if there is very thin components are there, if it is made by conventional milling or conventional other processes, so there is a chance of making bars. So these bars are actually unwanted during fabrication process. So while in conventional machining process these bars are actually made, so it is unwanted, but in chemical machining process there is no chance of making bars. Okay, so whatever surface you get, that is bars free. So this chemical machining is used for making printed circuit board. It is very famous in jewelry industries. Whatever these intricate components of jewelries are made by this engraving process, chemical machining process. So this turbine engine containment rings are actually made of by chemical machining process. Pressure vessel bulkheads are made of this chemical machining process. Some of the sheet metal components are also manufactured by chemical machining process. So if you make this one by chemical machining process with a single sheet, you can make a total component or product. So you can avoid this welding or riveting, all such kind of operations where this strength of the base material is actually weakened. So you can avoid this kind of thing by doing these sheet metal operations also. You can do the chemical machining operation and you can make certain products. So there are two things are there. One is called chemical milling, another one is the chemical blanking. So in chemical milling process actually blind holes like blind pockets are actually generated. So material is removed to produce blind details, pockets or channels etc. to reduce the weight. So in milling process actually, chemical milling process, blind details are actually generated. But in case of chemical blanking process, through components with through details are actually generated, through holes. So used for production of the through cavities. So through holes or through slots which are generated by this process, that is called chemical blanking. Also used for blanking complete parts from the sheet by chemically etching periphery of the desired shape. So these are the different applications of chemical machining process. So what are the different steps of chemical machining? So first you have to clean the workpiece properly. So if you don't clean it properly, what happens? What about these masking materials? It cannot be glued on the workpiece surface. If some dirty materials are there on the workpiece surface, it cannot be glued properly. So this masking, it will be debonded during etching process. So if it is debonded, what happens? There will be stray cutting will be there. So masking actually it is given, it is deposited on the workpiece surface to resist the chemical reaction into that area where this maskant is deposited. What this maskant, if it is removed from that portion, there will be stray cutting, unwanted machining will be there from the workpiece surface. So cleaning of the workpiece is a must. So it can be cleaned, it may be cleaned by alkaline solution or washed with the fresh water. So after that we have to put a maskant coat by one of the following methods. There are different methods are there for depositing this maskant on the workpiece surface. One method is the cut and peel method. Second one is the screen method, and third one is the photochemical method or photoresist method. Photoresist method, sometimes it is called a photochemical method also, photochemical machining also. So this maskant actually protects the workpiece surface from chemical attack. After depositing the maskant on the workpiece surface, this workpiece is actually deposited or dipped inside a chemical or etchant bath for desired duration of time for getting exact machining depth. So take the workpiece out after this machining from the etchant bath and remove the maskant layer. So after removing the workpiece from the etchant bath, you have to remove the maskant layer, and after that again it has to be cleaned thoroughly under fresh water. So these are the steps of chemical machining process. So sometimes it is chemically cleaned also. Initially this workpiece it may be cleaned by alkaline cleaning, or it may be cleaned by water. Sometimes it is cleaned by chemical cleaning to ensure proper adhesion of the masking material with the workpiece surface. In case of debonding of the masking, stray etching will occur. Already we have discussed. So there are different types of cleaning is there. First one is the vapor degreasing. So whatever these oiling materials are there, it may be removed by vapor degreasing process, or it may be cleaned by alkaline etching, etc., depending upon what kind of maskant you are using. So this cleaning process actually depends on what kind of maskants you are using, what kind of workpiece you are machining, workpiece material and required machine depth, how much machine depth you are doing. So this cleaning process depends on these parameters. So cleaning of porous material is very difficult because this porous material is because of this porosity. So it is very difficult to clean the porous material. So during machining, to avoid the uneven material removal rate, fresh etchant is continuously supplied into the etchant bath, or certain portion of the etchant actually removed from the etchant bath and it is replenished with the fresh etchant. Or you can, so either you can add etchant into that etchant bath, or you can take away certain portion of the etchant from the etchant bath and replenish with the fresh etchant.